Okay, so for number 12, I know it said converse. I want you to change that to say inverse, because inverse is going to be what's on your test. So it says, what is the inverse of the given conditional statement? And our statement says, if there is lightning, then it is storming outside. What the inverse says to do is that you're going to take your hypothesis and your conclusion and negate them. And negate basically just means to add not in these sentences. So if it says, if there is lightning, then the inverse would say, if there is not lightning, okay, then it is storming outside, so the inverse would say, then it is not storming outside. Okay, flip to the back. Number 13. This says if segments DM and ME are in the same plane, then DM plus ME equals DE. Which of the following describes a situation that disproves this statement? Okay, so I'm going to show you an example of when this is true. Okay, so let's say that we've got DM, D, M, and E. So it doesn't matter if DM is larger than ME, because they still add up to make segment DE. The reverse is also true. If DM is super short and ME is super long, when you add them together, they still make DE. So these are situations and when this is both true. So these are true and that's true. So that doesn't work to disprove this statement. Okay. Now, if D, M, and E are not collinear, so here's D, here's M, and here's E. So there's DM, there's ME, and DE is this line. So this is the case which makes this statement not true. Okay? Because if D, M, and E are not collinear, then DE doesn't even have point M on it. So you couldn't say that DM plus ME equals DE because M isn't even on this line. This forms a triangle, not a line. So we cannot say that these add up to equal DE. They're not collinear. So this is the case which disproves that statement. Okay. This last one, if they're coplanar, well, these are coplanar, but it doesn't make this statement true. So this is not necessarily a counterexample, okay? Because also these are coplanar. So just because something is coplanar doesn't mean that it makes this false. Okay. Number 15, find the endpoint of the given endpoint and midpoint. So this is like the other problem that was on the front. It's just another example. So we're going to make our X and Y table. We need it to have 3 sections. On top, I'm going to put my endpoint. In the middle, I'm going to put my midpoint. Okay. From 6 to negative 8. I am subtracting 14. Okay, so I'm going to do that again. 6 minus 14 equals negative 8, minus another 14 equals negative 22. Okay. Now on the other side, from -2 to +6, I am adding 8. So I'm going to do that again. And that gives me 14. And that's my other endpoint.